So I'd like to welcome Ian. He is a retired water resource engineer who grew up and currently lives in a forest on the Oak Ridges Moraine north of Whitby. 15 years ago, Ian and other neighbors noticed trucks dumping soil into an award-winning rehabilitation. And as Lake Ridge citizens for clean water, they researched the issue of fill, engaged the community, and dealt with officials to obtain an injunction. Working with other groups dealing with fill sites in their neighborhoods, Ian and his colleagues formed a nonprofit corporation, Ontario Soil Regulation Task Force, to successfully press for municipal bylaws, change in Federal Aeronautics Act, and provincial soil regulation. Ian is also involved with Storm, Save the Oak Ridges Moraine, and so I'd like to welcome Ian to give us his presentation on the implications of fill. Welcome, Ian.
Thank you, Erica. It's an honor to be here. What I'm going to do is I'm going to talk a little bit about fill, sort of give you the fill 101, and then go on to the concerns. Next, please. There's a lot of fill to go looking for a place to dump in Ontario. There's 16 Rogers Centers, or sky domes as you prefer, filled to the roof each year. That's a lot of soil. Next. Fill is now defined as excess construction soil. This comes from excavation for homes and subways and that sort of thing. And it also is contaminated soil from old industrial lands. And where does that soil go? In the past, it went to Leslie Spit and that whole area in Toronto between Front Street and the lake. That's all fill. But people in Toronto don't want to do that anymore. So it went to municipal landfills for a little bit, but that's stopping. A few years back, it was used to create flat aerodromes in valleys, but we stopped that. Now it's going to farmers' fields and into gravel pits. Next. And the other Ian mentioned the Ontario Regulation 40619 from 2019. And it says that excess soil is a waste, except under certain conditions. And it says it's not a waste if it's reused beneficially. And it's basically if the soil is dry and it meets certain quality standards, and it's going to a reuse site where there is a site-specific instrument. Next. And that instrument is basically what they're doing is they're passing responsibility over to another agency. For example, to a municipality who would use their municipal bylaw, their fill bylaw to manage it, or it goes into the Aggregate Resources Act as a pit rehabilitation if the license has not yet been surrendered. One annoying thing is these site-specific instruments can have lower standards than what the ministry scientists had determined to be safe. But because we generally are running these rules underneath the municipal bylaws, the municipality is very important to make sure things are nice and clean and we are looked after. So strong bylaws are important. Next. Fill concerns. There's modification of the landform. The Oak Ridges Moraine Conservation Plan in Section 30 tries to protect the landforms of the Oak Ridges Moraine because these fill sites generally take a nice rolling landscape and make it dead level and looking kind of ugly. There's importation of undesired species, basically bringing in seeds, weeds, whatever. There's changes to the infiltration. When you take out soil and gravel and fill it in with clay, you change the infiltration of the groundwater and the runoff to streams. But what most people get concerned with initially is the nuisance factors, all that truck traffic, about 1,000 trucks a day running down the road with all the noise, tailgates banging, a lot of dust. You're going to hear a little bit more of that on the next presentation. But municipal bylaws apply to try to deal with that. Our main concern right now is on contamination. There's two types. There's debris, which quite often can be construction waste, but it also means garbage, basically. And if there's any debris or garbage in the soil, the waste regulations apply, and the Ministry of Environment is probably, it's pretty good at at enforcing against dumping of waste. And then there's the chemical contamination. Next. Here's one example. Sheep farm took some soil, turned to be toxic to sheep. Next. This is the rehabilitated pit that Carmela, Marshall, and I and others got us involved. After pushing the officials to do some testing on site, they found cyanide 3,000 times the acceptable limit. One thing to note here is that it took 5 years before that showed up in a monitoring well, so immediate testing doesn't really tell you what's happening. And their point, I guess, is that that cyanide is still there in the groundwater and is still moving down slope. Next. Now, you hear a lot of talk about soil tables when you get into this, and they're basically short-term classifications for the type of contamination. Table 1 is considered basically natural soil, the cleanest that it's possible. Table 2 is soil that has a bit more contamination, but it's still clean enough to be able to be put near your groundwater wells. If it's table 3, it's got even bit more contamination, and it should only be in a spot where people are on town water and don't rely on groundwater. But if there's any contamination over table 3, then it's a waste, and the waste rules apply, and the Ministry of Environment gets involved again. There are all kinds of different tables, but basically 1, 2, and 3 are your primary classifications. Next. This is what a soil table looks like. There's many tables. This is the start of the one for table 2 in a potable groundwater situation like you're in. And you can see it, you can't read that maybe, but it's chemicals and the A's and into the B's. There's about 200 there involved. It takes about $2,000 to get a sample analyzed in the lab. Another point to make is there is no definition for clean fill. If you ask a guy for clean fill and he dumps some demolition waste in your yard, you have a tough time suing him because there's no definition for clean fill. So that term is meaningless. Next. So soil is tested. Sounds really great. Before it leaves the source site, it gets tested. However, the test samples are very, very small. 1 thimbleful of soil from 1 truck to represent, at a good sampling rate, 50 different trucks. So it's quite easy for contamination to slip through. Next slide. Now on that last slide, anybody see the truck dumping the red soil? That sort of shows you how hard it is to identify if there has been contamination or not. And that means that inspections and sampling and testing have to be done at the receiving site. This picture here is a drill rig that takes a core way down to the natural subsoil underneath, and out of that they'll take a few thimblefuls of soil and test for contaminants. But we've found in our results that even though the source site said the soil was clean, they had the test results. Once it was dumped, we could take a look. We do find contamination over the limits. Next slide. Now we started, it was a community organization, just a bunch of volunteers doing some research and pushing, and it's now a big business. There's lots of lawyers involved, there's lots of engineers involved, there's lots of soil specialists, there's lobbyists as well. This picture is of a symposium that occurs every year, and you can see you get hundreds of professionals there talking about management of excess soil. So it sounds pretty good, as though we've got regulations in place and people are interested and have a business to make sure that the soil meets the regulations. However, next slide. There's organized crime. People can make an awful lot of money by taking contaminated or hazardous soil and passing it off as, to use the improper term, clean fill. About $6,000 per truck. This is what a lawyer calculated. The other big problem we have now is that they're allowing excess construction soil to go into the groundwater. Normally, those wouldn't be too much of a problem because in the past there were very few pits in groundwater, in other words, with groundwater ponds in them. However, the Agri Resources Act was changed recently to allow excavation into the groundwater. So this is our other concern. Next slide. So excess soil below the water table. Keeping soil away from the water is the key goal of the soil regulations. You read through the regulations, and well, for one, there's classification for overground potable groundwater or not. They say dry soil only. They specify minimum distances from the soil to any surface water, ditches or whatever. There's minimum distance between the soil and the water table. Yeah, they stay above. They talk about capping the sites so that there no infiltration will leach the chemicals out to the groundwater. And one of the main testing methods for soil is a leachate test to see how many chemicals are leached out of the soil into the groundwater. So they are very concerned about contact of soil and water. Next. Other concerns are that contamination limits are revised every few years. You never really know what the impact's going to be in the future. If you're as old as I am, you probably remember when asbestos, lead, and mercury were perfectly acceptable to have around your home. But apparently they're not acceptable now. And this may happen with some of the stuff that's in the soils and leaches into the groundwater. I mentioned leachate, the soil leachate test. The standards for that test come right up against the drinking water standard. So in other words, a leachate test that just barely fails the leachate test does not meet the drinking water standard. So they're so close that you don't really want to be there. And as a little mention, that when they develop the best practice that sort of allows soil going into the groundwater, they used very poor science in that study, but it was one of the things that got pushed through during the COVID period when there was not a lot of discussion or chance for meetings. Next slide. And just sort of to round, end up and do with a summary here, concerns about what's going on here is when you got soil going into groundwater, you have potentials for chemical contamination. There's potential for bacterial contamination with bacteria and viruses being flushed out of the water or the soil straight into the groundwater. There could be turbidity, things just you're stirring up soil and water. It gets muddy and dirty. They can affect the color and the taste. And as you know, when a neighbor is drilling a well or messing with the groundwater, it can possibly affect your flow and the levels in a well. And that's all I have for the moment, but I'll be around for any questions.